Fun fact, mercury and bromine are the only two elements that are liquid at room temperature. The state of matter of different elements and compounds are determined by what is called intramolecular forces. These are electrostatic forces that essentially determine how well the atoms stick to each other. In the case of mercury, it forms a relatively unique electron configuration that is a lot less susceptible to forming stronger intramolecular forces. Here is the electron configuration for mercury, and you can see that 6s orbital has 2 electrons in it. Now, the reason that 6s orbital is a lot less likely to form strong intramolecular forces gets into some more complicated relativistic effects, but for now, just think of it as mercury does not really like to give away its electron as easily as other metals do, and therefore forms much weaker forces between molecules of mercury compared to other metals. The result of this is that mercury is actually a liquid at room temperature. In the case of bromine, the reason that it is a liquid at room temperature has more to do with the atomic size, which of course affects those intramolecular forces. Atomic size increases as you move down a group in the periodic table. And the reason for that is because the atoms have more electrons that have to fill other electron orbitals, and therefore it just gets farther away from the nucleus, creating a bigger atom in general. Atoms with bigger atomic radii have much stronger London dispersion or intramolecular forces amongst themselves. Because those electrons are farther away from the positively charged nucleus, there's a much weaker hold of them, and therefore it is much more likely to let go or share these electrons with neighboring atoms, forming stronger intramolecular forces. Bromine hits a sort of Goldilocks zone. For example, iodine, its intramolecular forces are so strong that it's actually going to form a metal at room temperature. Chlorine, they're so weak that it actually forms a gas at room temperature. But bromine happens to be right in the middle and is able to be, of course, a liquid at room temperature. Isn't that interesting? Isn't that fun?